In applied science, applied mathematics, physical science, most importantly, engineering, we usually have a mathematical solution, mathematical model to some certain problem, and we provide solution to such problem using mathematical approach. In our mathematical approach, we encounter various unknown constants, and finding the value of these unknown constants will make us to provide a solution to this certain problem. In our approach as well, either we are using differential equation in our approach, Laplace transform in our approach, or we have various set of linear equation. It is very important to find these unknown constants because it is a key to modeling and simulation in science. You are welcome to Dynamic Educational Hub channel, your answer to the very question, and this is a channel where I dissect various topics in mathematics, physics, and chemistry. If this is your first time of coming across my channel, kindly subscribe to my channel, click on the notification icon, like and share this video. What are we learning in this video? We are going to learn determinant method, which is also Cramer Rule, how we can use it to solve set of linear equation having 2 unknown and 3 unknown. Without wasting time, let's start the video. The first thing which we want to do is we want to get the background knowledge of determinant method. So let's have set of linear equation having 2 unknown. Let's have it. So we have a1x plus b1y is equals to c1. Let's call it equation 1, and a2x plus b2y equals to c2. Let's call it the equation 2. Now we have our matrix as shown, coefficient of x and coefficient of y, and our answers. Now if we write it as our augmented matrix, so we have this as our augmented matrix, the next thing is let's see what will happen
when we delete the C column.
After deleting this, let's call the new matrix, let's call it C0, and let's try to find the determinant. Finding the determinant, we have a1 b2 minus a2 b1 for this. Now let's try to delete x, and let's call the matrix, let's call it x0, and let's find the determinant. Finding the determinant, we are going to get b1 c2 minus c2 minus b2 c1, and that is the value of the x0 determinant. Finally, let's delete the y column. Deleting the y column, will be left with a matrix a1 a2 c1 c2, and let's call it y0. Let's find the determinant of y0, which is a1 c2 minus a2 c1. We'll see the reason why we are doing this. Now let's apply our previous knowledge on algebra. Let's apply it, and let's try to eliminate y from this set of linear equation. To eliminate y, we are going to work with the coefficient of y in the first equation and the second equation. We swap the coefficient, we multiply it. So to eliminate y, we multiply equation 1 by b2. So we want to multiply equation 1 by b2. Multiplying it by b2, we're going to have a1 b2x plus b1 b2y is equals to b2 c1. Then we multiply equation 2 by what? Multiply equation 2 by b1. Multiplying it by b1, we are going to have a2 b1x plus b1 b2y is equals to b1 c2. Let's call it the fourth equation. Since we want to eliminate y and we look at the coefficient of y in the first and second equation, they are the same, so we can find their difference. Now finding the difference, we want to subtract equation 4 from 3. So equation 3 minus equation 4, let's have it this way, and let's subtract them. Subtracting them, for this one we are going to have a1 b2x minus a2 b1x. So this minus this, and this minus this will be left with nothing, 0. So we are not using it again. Is equals to this minus this. So that is B2C1 minus B1C2. Since we want to make x the subject of this, so we want to find the value of x in terms of a, b, and c. So we can factorize x here. Bring out your x, the left hand side, bring out your x. So we'll be left with a1 b2 minus a2 b1, and is equals to this guy over here. We can divide the two sides by this. Dividing the two sides by this, we'll be left with b2c1 minus b1c2 over a1 b2 minus a2 b1, and that is x in terms of a, b, c. Let's quickly do a check. Don't forget what we have done earlier on, the determinants we found. Let's try to see if we have anyone that looks like the previous determinants we have gotten. Let's find b2c1. We have it here, b2c1, and let's look at it. They are not the same, but we can apply previous knowledge in mathematics. We can apply it to make it the same. And what are we going to do? We want to have b1c2 minus b2c1. We want to change this into that. And how can we achieve that? Let's try to write minus b1c2 first. Writing it, so we are going to have minus b1c2 plus this guy. So I'm just writing it as if we are doing 3 minus 2 and we are writing 2 first. That will give us, it's still the same thing as minus 2 plus 3. That is what I've done here over this. Now the next thing is we can still factorize this guy. Factorizing it, bringing out minus 1 or minus. If you factorize it, bringing out your minus, dividing this one by minus, we'll be left with b1 c2, and dividing this one. Forget the denominator. If you look at the denominator, you find out that for the denominator is already c naught determinant of c naught. Look at it and look at it here. Bringing out your minus like this, so we have b1 c2 minus b2 c1 over a1 b2 minus a2 b1, and this is Cramer Rule. Let's observe it very well. Observing b1 c2 minus b2 c1, we have determinant of x naught over determinant of c naught. So basically we discover that x is what? Minus determinant of x naught over determinant of c naught. That is x. Now let's try to do the same thing for y. And that is what we have here. Doing the same thing for y, this time around we want to eliminate x from this equation. To eliminate x, we are going to multiply, just like elimination method in simultaneous equation, multiply equation 1 by a2 and equation 2 by a1. Now to eliminate x, multiply equation 1 by a2. So that is what we have. Multiplying it by a2, we are going to have a1 a2x plus a2 b1y is equals to a2 c1. Then we call it equation 5, the fifth equation. Multiply equation 2 by a1. This guy, I want to multiply it by a1. Multiplying it by a1, we have a1 a2x plus a1 b2y is equals to a1 c2. Let's call it our sixth equation. Since we want to eliminate x, we can find the difference. Finding the difference, we subtract equation 5, we subtract equation 6 from equation 5, equation 5 minus equation 6. This guy is the same, so we are not going to use it again. So we are left with this guy. That will give us a2 b1y minus a1 b2y is equals to a2 c1 minus a1 c2. That is what we have here. And we can factorize this. Factorizing that, what are we going to have? Bring out your y, divide this one by y. You have a2 b1 minus a1 b2 is equals to a2 c1 minus a1 c2. And divide both sides by a2 b1 minus a1 b2. Dividing both sides by that, which means that we want to make y sort of formula. Doing that, we have A2C1 minus A1C2 over A2B1 minus A1B2. Let's quickly do a check. Let's move to Y not determinants. Y not determinants, we have A1C2 minus A2C1. Oh, that is what we have here, and it's not the same, but it looks alike. Let's look at the denominator as well. A2B1, we have A1B2. It looks like this, but it's not the same, but we can still perform operation like we did in the first one that we've done, which is X. Now to do that, we can rewrite this as well. Rewriting them, we want to factorize the numerator by bringing out minus 1 or minus, and denominator by bringing out minus 1 or minus. We are doing that in order to make this numerator and denominator looks like the determinant that we've calculated earlier on. Now doing that, bringing out minus, what are we going to have? You divide this one by minus, so obviously it is carrying minus. Divide this one by minus, it turns to plus. Divide this by minus, it turns to minus. Divide this by minus, it turns to plus. Now we have this. We can rewrite the numerator and the denominator, the one that are inside the bracket. Rewriting them, don't forget your minus is outside. It means that we want to write A1C2 first minus A2C1 here. The same thing, you are writing A1B2 first minus A2B1, and that is what we have over here. Looking at it carefully, we can see that this has conformed to what we've done earlier on. So which means that Y is equals to A1C2 minus A2C1, which happens to be determinant of Y naught, over A1B2 minus A2B1, which happens to be determinant of C naught. And looking at it, we have this, we have that, and that is also Cramer rule. We derive an expression for finding the value of x and y while solving two sets of linear equations having two unknowns. Now what about three sets of unknown, three sets of linear equations? Now we have this, which happens to be three sets of linear equations with three unknown constants. To solve that as well, the first thing is we write it like this, and we write our augmented matrix. The same thing we've done with the two equation, we will still apply it with this equation. Now, which means that we are going to delete the D column. We are going to delete that column. Deleting it, whatever matrix we have here, we can find the determinant. Whatever matrix we have, we call it D naught, and we can find the determinant. We delete the X column, we are left with this matrix. This matrix as well, we call it X naught, and we can also find the determinant. The next one, we delete Y column, we are left with this matrix. This matrix is called Y naught, and we can find the determinant. Finally, we delete Z, the column Z, and we are left with a matrix that is called Z naught. We can also find the determinant. Now after we found the determinant, and if we apply the same method that we've done for two sets of linear equations, we'll still get the same thing, which means that X will also give us X naught determinant over D naught determinant, and Y will be minus Y naught determinant over D naught determinant, and Z will also be what? Z naught determinant over D naught determinant. This is how to find the unknown constants in set of linear equations for 3 by 3. For 2 by 2, the first one will carry negative, while the second one will carry positive. And for 3 by 3, the first one will carry positive, the next one will carry negative, and the next one will also carry positive. Is the formula you can use to quickly find the unknown in set of linear equation 3 by 3. Let's see how to apply this and let's see how to use it to solve.
In the next video, we are going to apply this and use it to solve set of linear equation having multiple unknown. If you are yet to subscribe to my channel, kindly subscribe to this channel, click on the notification icon, comment in the comment section about your view, like and share this video. One way of promoting this channel is subscribing and sharing my video. Alright, before we end this video, let me quickly do a recap.
What we learned is we derive an expression which is determinants and how we can use it to find determinants of set of linear equation. For two sets of linear equation, we use this expression, and for three sets of linear equation, we use this expression, and this is Cramer Rule. We can use it to find the unknown constants in set of linear equation. Alright, see you in the next video, which is going to be an interesting one. Bye for now.